All right, let's talk about building a truly resilient production-grade EKS cluster. We're going to go way beyond the basics here to architect something that can actually handle real-world failures. So let's dive right in. So let me ask you something straight up. Take a good hard look at the setup you're running right now and ask yourself, is it really highly available? Are you confident it could survive a major outage? Because, a lot of setups that look solid on paper have a single point of failure just hiding under the surface. And look, if you think high availability is just about spinning up a couple of extra worker nodes, well, you're kind of missing the bigger picture. Real resilience is a multi-layered strategy, and that's exactly what we're going to build out together right now. Okay, so here's our game plan. We'll start by busting the HA myth and then break it all down into 4 distinct layers. We'll run through a non-negotiable checklist and tackle the places where things usually break, like storage. Then, I'll introduce you to a secret weapon for healing your capacity, and finally, we'll pull it all together into the ultimate production blueprint. The first thing you've got to get your head around is that high availability on EKS is a shared responsibility. It's not just some switch you flip. It's a stack that you and AWS build together. And that stack has exactly 4 layers. Yep, 4. And trust me, if you forget even one of them, the whole thing can come tumbling down. So let's break them down one by one. Layer 1, this is the easy one. This is the freebie. It's the EKS control plane, and AWS manages it completely for you. It's already highly available, right out of the box, running across multiple availability zones. You don't have to worry about the master nodes or etcd. That is all on them. But now, this is where your job starts. Layer 2 is the network foundation, and this is critical. You absolutely have to build your VPC across at least 2, but really, you should be using 3 availability zones. Your subnets, your routing, everything has to be designed so that if an entire AZ just disappears, your cluster doesn't even flinch. Next up, Layer 3, your worker nodes. It's not enough to just have a multi-AZ network. The nodes themselves have to be spread across those AZs, using different node groups. And here's a pro tip for you. Use multiple instance types. Why? Because if there's a capacity crunch for one specific instance type in a region, it won't take your whole cluster down with it. And finally, we get to Layer 4, the application itself. Honestly, this is usually the trickiest part of the whole puzzle that you have to solve. It covers everything from how your pods survive disruptions to how they scale, and, super importantly, how you're handling your traffic and any persistent data. Okay, so we've got the layers. Now let's get super practical with a core HA checklist. Think of these as the absolute must-do non-negotiables. If you're not doing these things, you're just not running a highly available application. Simple as that. First, you have to enforce multi-AZ placement for your pods, using things like topology spread constraints. Second, you need to be using pod disruption budgets, or PDBs. They stop you from accidentally taking down all your application replicas at once during something like a node upgrade. And third, you have to configure liveness and readiness probes. Without them, Kubernetes will just keep sending traffic to pods that are dead or dying. Not good. Okay, let's talk about the parts of the stack where things really tend to fall apart. Storage and traffic. And of those two, let me tell you, storage is the silent killer of HA dreams. No, I'm serious. I can't stress this enough. When people get storage wrong, they create this illusion of high availability. Your app might look like it's spread out across multiple zones, but really, it's just tied to a single point of failure, waiting to bring you down. And this all boils down to a fundamental choice between something like EBS and EFS. EBS, your standard block storage, is locked to a single availability zone. So if a pod fails and gets rescheduled to another AZ, it's lost its storage. EFS, on the other hand, is multi-AZ from the ground up, which makes it an amazing choice for things like shared data. But here's the real pro move. For your most critical, stateful stuff, we're talking production databases, the most resilient architecture is to just move it outside the cluster completely. Use a managed service like Amazon RDS with multi-AZ turned on. Let AWS deal with that heavy lifting. Okay, so you've done everything right. Your nodes are spread out, your pods are distributed, but then it happens. An entire availability zone actually fails. Poof, gone. How does your cluster recover the capacity it just lost? Well, this is where your secret weapon comes into play. Meet the cluster autoscaler. Its job sounds simple, but it is absolutely vital. It watches for pods that can't get scheduled, and then it automatically adds new nodes to the cluster so they have a place to run. In a failure scenario, this isn't just about scaling for load, it's about healing your cluster. So look where the cluster autoscaler fits into our layered model. You see, all the other components are about being resilient, they're static. The autoscaler is the dynamic piece of the puzzle. It is the component that actively restores the capacity you lost. It's not just a scaler, it's the capacity healer. And this brings us to a classic interview question that perfectly tests this exact knowledge. So, how would you answer this? Your response pretty much reveals whether you really get how dynamic recovery works. And here's the subtle but critical difference. The common, wrong answer is, oh, the pods will move to other AZs. But pods don't move. They get terminated and then rescheduled. The correct answer explains that process. And, most importantly, it names the cluster autoscaler as the hero of the story, the tool that provisions brand new nodes in the surviving AZs to handle the load. Okay, we've covered the layers, we've gone through the checklist, we've unveiled the secret weapon. Now it's time to put all of these pieces together into one single, comprehensive blueprint for a production-grade, highly available EKS cluster. And this is it. This is the whole shebang. Up top, the AWS-managed control plane. The foundation is a VPC spanning 3 AZs, each with its own NOT gateway for resilience. Inside, we have node groups mixing on-demand and spot instances, all managed by our hero, the cluster autoscaler. The AWS load balancer controller handles traffic, our pods are protected with PDBs and health probes, and, critically, our most important data, our state, is managed outside the cluster in something like RDS or EFS. This is your master checklist. So, I'll leave you with this. Looking at this blueprint and thinking back to your own environment, what's your weakest link? Is it your storage strategy? Are you missing pod disruption budgets? Or maybe you don't have a real plan for capacity recovery? Finding that single point of failure, that's your next step to building a truly unbreakable system.